Good morning, good afternoon, good evening, everybody. My name is Kartik, one of the co-founders of ETH Global, and I'm super excited to welcome all of you to Scaling Ethereum. You're all watching this on ethglobal.tv. This is the platform we'll be using for the next few weeks. This is where all the talks, workshops, or sessions will happen, especially all the closing and opening ceremonies where you get to see what's going on with the whole event. And this is an interactive platform, so you get to ask us questions, comment on things, and we get to see everything on our side in real time. So this hackathon is run by ETH Global. And for those of you who are joining us for the first time, we're an organization with a very simple mission. Our goal is to onboard thousands of developers into the Web3 ecosystem. And we do this primarily by running hackathons and summits, both in person and async. And Scaling Ethereum is our async event. That's the third iteration of this massive event. So what I want to spend the next few minutes on is walking through all the things that you need to know to get ready for the next few weeks for this hackathon. We have over 700 hackers from 73 different countries, spanning 23 different time zones participating. And just to kind of see where everybody came from, it is incredible to see representation from 6 different continents and so many cities, hundreds of cities. And of course, it's always amazing to see somebody get excited about building and helping scale Ethereum from all parts of the world.
Well, usually for the ETH Global Hackathons, I've been focusing mainly on healthcare projects. I think I'm going to do the same, and that's one of the reasons why I'm wanting to learn and build with Nillion and see where I can go there. My idea right now for the project is to try and showcase where in healthcare, if you have different networks, it's possible where the data that like the healthcare that you get is different from a network that you're a participant in. So I wanted to see if I can create a project to showcase where a protocol or something could leverage sharing information without revealing, which might allow, for instance, you have a patient that's able to run their tests through different healthcare networks to get the best possible diagnosis for something. So that's the goal. We'll see how far I can get on that. But yeah, usually I try to build something with a better use case. I'm not really into, like the DeFi as much or socials, more into healthcare type of applications, something that's I just feel more meaningful. Healthcare is a space that I used to work in and, just find it more meaningful. Hey, I'm Chris, and I am doing the ETH Global Scaling Ethereum Hackathon. And I plan to build a project using Nillion. And I've done a few hackathons in the past, and a lot of the focus is primarily in privacy. I worked in healthcare previously. So let's take a look at the docs here. Let's go first into what is Nillion. It's a secure computation network that decentralizes trust for high value data in the same way that blockchains decentralize transactions. They highlight 3 things here: the need for secure storage, the ability to compute on stored data without compromising security. I think that's an important, definitely right there. Achieving decentralization of data management. So Nillion uses this privacy enhancing technologies, which is using multi-party computations. And what they're basically allowing is users to store high value data on Nillion's network by masking the data itself, basically allowing you to compute on data without having to decrypt or unencrypt. So when they talk about high value data, it's something extremely valuable to an organization or an individual. And so, all right, we can take a look at the chief scientist blog, see what he got to say. Miguel de Vega, January 2024. In today's digital landscape, the increasing value of data has led to a growing fragmentation of trust, especially around high value data. As organizations and individuals become more reliant on digital systems to store, process, and transmit sensitive data, concerns around privacy, security, and data integrity are at an all-time high. It's a lot of keywords. HVD refers to data that is extremely valuable to an organization or an individual. Web3 is cementing itself as a new layer of the internet, underpinned by the blockchains and decentralized infrastructure, value propositions. All right, decentralization is growing to mean far more than the wood networks being designed to apply trust, minimize, and fault-tolerant design to niches like file storage. So Nillion's primary focus on privacy enhancing technologies, PETs, zero knowledge proof, which is what I'm more familiar in, are leveraged to add varying amounts of confidentiality to movements on the ledger. There's also trust executed environments, TEs, and fully homomorphic encryption. So data privacy can be a tool that opens up the design space of what is possible with trusted minimized networks. The notion of privacy in Web3 has become synonymous with private currencies and preventing on-chain traceability. These protocols are exceedingly important parts of the ecosystem that are necessary for crypto to thrive, but privacy and security are also important tools for onboarding real-world use cases and enabling novel on-chain applications, especially in the context of data. Pets can disintermediate the privileged actors that control the flow of the world's high-value data. So let's continue. High-value data as a category is a significant opportunity to expand the impact of Web3. Agree, both within the crypto ecosystems as well as the alternative to traditional centralized systems. On the other hand, traditional centralized entities have struggled with safeguarding high-value data, which has led to significant breaches that highlight the opportunity for a fundamentally new approach to data security. I agree. And, if you're not trying, then, you're not really trying. So, what works right now is those centralized entities, until it's not, which I don't really see it going away anytime soon. So let's keep going. MPC. So traditional data handling follows a decrypt, compute, re-encrypt cycle. Data has to be decrypted in order to run a computation and then re-encrypted for storage or transmission. Decrypted data is vulnerable to unauthorized access and potential security breaches, exposing sensitive information during the computation phase. MPC enables computation over inputs from multiple parties while keeping the actual data hidden. The data remains confidential throughout the entire process, not only when it's stored or in transit, but also during the actual computation. With MPC, you can collaborate to compute on hidden secrets without ever revealing the actual secrets. I used to work in healthcare, so most of the projects that I've worked on in the past have been healthcare focused and primarily with zero knowledge. And when Nillion got into the Web3 scene, I thought it was interesting and, it's probably worth the look. The idea is if you have a patient and this patient is part of a specific health network, the hope is in the event that you need to get a diagnosis that you can run your, the data on you onto, any health network's aggregated set of data, to give you a fair diagnosis across the whole healthcare data spectrum that's available. Nillion's MPC protocol looks like it's split up into two phases. We have the pre-processing to create shares. So basically, we're preparing for the data for the network to handle these high-value data. And it's pre-processed to generate and distribute shares, which basically are masked for each factor and term in the sum of products that's used in the MPC techniques. So it only depends on the number of inputs so that the appropriate number of shares are created ahead of the computation. And then phase 2 is the non-interactive computation of the mask factors. And there are basically 3 stages in this phase. You have the input stage, basically where one party receives a share per input, and the parties combine their inputs to create mask factors. These multiplicative homomorphic mask factors are broadcasted to the network, which maintains the information theoretic security ITS. Then you have the evaluation stage where it's utilizing the computationally homomorphic properties of the mask factors and enables operations like addition and multiplication to be carried out directly onto this mask data. And then the output stage for the result. So the features of Nillion is non-linear arithmetic capabilities. Protocols can evaluate sum of products of hidden inputs without leaking input information to any other parties. Efficient pre-processing and asynchronous combination. That's just speed, ITS security. So let's get started. All right, so let's go ahead and get started with the JavaScript Developer Quickstart. We have several steps here. Be installing the SDK, setting up the dev environment, and we'll be running the Nillion DevNet on the local network. We'll create a NADA program, and we'll connect to the network with the client to store programs, store secrets, and compute on programs. So let's go ahead and just go through the process. I've already done this, but just to show. So we'll use the curl command to install Nillup. Oops. And then we'll go ahead and install latest. And then we'll use the use latest. Oops. And then the Nillup init will probably fail here because it's already been done. I'm gonna not do the telemetry for now. See how far I go. All right, so let's clone the JavaScript starter repo. Install the repo dependencies. Should already have these. If not, this is what you'll probably need to follow. Install. MetaMask browser and stick extension. Just add this to Brave extension. caution, experimental software. Let's go accept. You agree. Let's create a new wallet. Help us improve MetaMask. Usually just opt out to these things. Create a password. Create a password here. And then you can get your recovery phrase. I'll go ahead and get this here. So I'll just come back a quick one. All right, once we got the password created and the recovery seed saved, go ahead and continue. Let's go through this another time. Let's go ahead and create an account. Let's call this dev01. All right, so we got that set up. Let's go ahead and pin it so I can see it. So let's go and generate a Nillion key. So let's just go ahead and see this here. I'm using a new profile in the Brave browser here. So there's no other extensions, but make sure you have everything else disabled other than the MetaMask Flask. Just accept here, connect to the Nillion. Let's go ahead and generate the key, store the key, and we got that stored. All right, so we're in the scaffold. Let's go ahead and we can just take a look at it. Let's go ahead and install dependencies. Then we'll run the Ethereum network with Yarn Chain and deploy the contract with Yarn Deploy. We'll wait till this passes. All right, let's go ahead and run the ETH network. And then we'll go ahead and deploy the smart contract. And then we'll run Nillion DevNet. So yarn all right, so once we have the Nillion DevNet, we'll go on to 5. Let's go ahead and say open another terminal to create an activated Python virtual environment. Just copy this here, paste that in. It'll create a Python virtual environment. We can see that now, this VNV. And then it wants us to cd into the next project programs directory. And we'll go ahead and just create that tiny secret edition py file. See that here. here we'll use the Nillion network MPC language Nada. The first implementation of Nada is a Python DSL. So let's go ahead and just copy this here. Looks like Nada is our program, and it's creating a party with the value name party1. We're creating 2 secret integer inputs that belong to party1, and the program will have the compute code to add the 2 integer inputs, and then it'll be returning an output. So that's from my understanding. So let's see what it says. Contains the code Nada main. Yep, we'll add party. So party1. Learn about inputs, Nada program have inputs, and input is defined with a name and a party, which is the party providing the input. So the name and the party. The Nada program inputs are typed. There are a few categories of types: secrecy level and scalar. So public, visible to all, secret values to be handled by computing nodes as shares or particles. And we have the type of integer and string. These categories are combined into secret types like secret integer. See all the types here. Primitive, public, secret literals. We have compound data types, experimental arrays, and tuples. All right, before we get into it, let's just keep going. So in the example they have here, Steph is in party, name of the party, and then the secret integer name is the number of dogs for the input, the name, and the input belongs to Steph. So here we can create 2 secret integer inputs. That's what we have here. The name of the integer input is myInt1, and it belongs to party1. Same with myInt2, the secret integer, which is an input that has the name of myInt2 and party1. And what it will do is we have that line here where we'll add the integers by creating a new variable, new integer. And you have the return line, this output. So let's see, it returns an array of outputs. So that's why we see the bracket here. Here's an example of an output. The output name is total score. It's a value of a scored integer. It can be read at a party name Steph. All right. All right, so we just wrote our first Nada program. Let's go ahead and compile it. So add the program path name and prime size to your Nada project TOML file. All right, so we just wrote our first program, first Nada program. So let's compile. We'll go ahead and go into this TOML file. And we're gonna add this here. So looks like we already have the main program. Then we have the simple addition. And then we're adding our tiny secret addition in the prime size. So just go run the build. Oh, sorry, got it in the wrong directory. So, and run that. All right, so that the build got completed. And then we're gonna copy the bin program file from, so it got created here in the target, and we're gonna copy that into the Next.js public programs folder. So we'll just take their command here, copy tiny secret, and should find it here. There you go. And then copy the Python file into the public programs folder for eventual use. Okay, so the bin file and the Python file goes in to the programs directory in the Next.js. All right, so let's spin up, open another terminal, and yarn start. This should run our Next.js app. All right, so here's the scaffold. And let's see, what does it want us to do? Visit the Nillion blind computation page. Edit the code to set the program name to Tiny Secret Edition. All right. So if we go here in the Next.js, shouldn't we go to the app, Nillion compute, have our page here. So we'll paste the Tiny Secret Edition, the name of our program here. That's going to initiate the state when it runs. So by doing that, sets the program name to the Tiny Secret Edition. Now the page will store and compute with the Tiny Secret Edition Py program we just wrote. Okay. Complete the to-dos in the hello world to hook up working Nillion. No, that's next. So let's go ahead and check this thing out. So if we go the blind competition demo here, let's connect. Just make sure. So we'll connect to our Nillion user key. And here is our stored Nada program. And then we have a section here to store secret integers with program bindings to the program. All right, so first let's go ahead and store the program. Okay. And then we can store our secrets. So maybe just go 1, 2, 3, 4. And then on here, I'll just use 1, 1, 1, 1. Submit on both. So I have the store IDs for both, and it's both were sent with my user key. So if you want to see what I entered, I'll just click here. So 1, 2, 3, 4 for my integer 1, and 1111 for integer 2. We'll now perform that blind computation with stored secrets. So if I should get the addition right there. So 1, 2, 3, 4 plus 1111 equals 2, 3, 4, 5. All right. It's pretty cool. This demo here has got me thinking. Basically create different parties. I can see myself creating a party probably for the patient. And then I will look into creating different parties that represents health networks. And from there, you're taking the patient's set of information, allowing it then to be passed to these other health networks data set where they're able to perform encryption or perform computation on encrypted data, and probably, give some form of diagnose value based on the patient's data in comparison to what their database contains. And then potentially the patient can have access to, 3 sets of data, or we could do an aggregate computation of all the health networks and receive one single diagnosis result. But that's what I'm just thinking in my head right now. We'll see how I continue to go here, but I think this blind computation mini program here is where I'll probably start. And yeah, so stay tuned.